Hey math kids, today we're going to talk about proof by exhaustion. And the first one gives us a statement, and we want to prove that n to the fifth minus n is always divisible by 5. So first I just want to show an example of what it's saying. So this is not the proof part yet. But if we plug in a 1, we get 1 to the fifth minus 1, which is just 1 minus 1, which is 0. And 0 is divisible by 5. Okay, if we plug in a 2, we get 2 to the fifth minus 2. That's going to be 32 minus 2, which is 30. And 30 is divisible by 5 because it gives us 6. So it wants us to prove that no matter what integer we plug in for n, this will always be divisible by 5. And so if we take in any integer or any n value and we divide it by 5, we're going to have a remainder of either 0, meaning it was divisible by 5, 1, 2, 3, or 4. So those are all the possible remainders. And so if we think of a number that's divisible by 5, it's going to be like 5 times some number, right? So we could write the number 10 as 5 times 2, and we know that 10 is divisible by 5. So we're going to have 5k. We're also going to think of 5k plus 1, 5k plus 2, 5k plus 3, and 5k plus 4. Those are all the possible things that we could have. Now, if we look at our original statement and we just set this equal to capital N, and just to make it easier when we're going to talk about it later in the proof, we know we're going to go through all of these possibilities. So if n is equal to 5k, then the factor n is divisible by 5, and so n is divisible by 5. Okay? So we don't really have to worry about it. Now, if n is equal to 5k plus 1, then okay, let's see, how can we do this? So on this first one right here, if n is 5k, so if this is 5k, then this entire thing is being multiplied by 5, so it's definitely divisible by 5. And so that's what we're saying right here. On this next one, if it's 5k plus 1, then we know that this thing, so if we did 5k plus 1 minus 1, so if I plugged it in, let's color code this. So if I plugged it into this, that simplifies down to 5k, so we know that it's divisible in that case. Okay, if n is equal to 5k plus 2, and we plug it in here, we get 5k plus 2 squared plus 1. We expand that out. We get 25k squared plus 10k plus 10k plus 4, and then plus this one right here. And we simplify that. Because we could factor out a 5 from that, we know that that's divisible by 5. Now, if n is equal to 5k plus 3, we can actually use that same factor So let's try that. 5k plus 3 quantity squared plus 1. So it's going to be 25k squared plus 15k plus 15k plus 9 plus 1. And if we just combine those into a 10, well, I guess I'll just do all of them. Okay, once again, we can factor out a 5 from this. And so it's definitely divisible by 5. And then if we get, if n is equal to 5k plus 4, we can look at this factor. And if we do 5k plus 4 plus 1, 5k plus 5, we can definitely factor out a 5. So it's divisible by 5. Okay, since we tried every single case that's possible, that's called proof by exhaustion. There's no other cases. All of them have been proven true. And so we know that this is always divisible by 5. If you need additional help, please come to Math Lab. Until then, calculator.